So I work for obviously Parks and Wildlife, and the area I focus on is paid through via environmental offsets through FMG, and the bulk of FMG's mines are in the Fortescue corridor, just near the Fortescue Marsh, which doesn't make a lot of sense, but it's quite close to Karragini, and so these are the mines here to the north. So to offset some of their impact, they pay for me and some operational funds to undertake work to mitigate those impacts, and I'll show some of them now. So this is a map of the area, obviously. I think we're up here somewhere, aren't we? And to the right here. And so the Fortescue Marsh, quite close to Karragini, about 110 k's north of Newman. It's quite a large area. This image here shows just looking across the Fortescue Marsh to the Hamersley Range. So it's a samphire land system, quinopods. So these plants are very tolerant to high levels of salt and inundation, as you can see here in the lower photo. So almost the same spot 6 months later after the wet season, 100,000 hectares of areas filled with water. Let's move that. How deep? 5 metres at the most. I don't know the volume it holds, but yeah, about 5 metres. Pretty flat. Sorry? It does. Many species, yes, and it just grows back. Yeah. So this is just another perspective showing the upper Fortescue catchment, over 3 million hectares in size. That's the marsh here over a very dry period. And in contrast, going the other way, over a wet period, so you can see the amount of water, the volume is enormous. So the whole catchment sort of draining into the Fortescue from the Chichesters to the north and the Hamersley to the south. That's Ophthalmia Dam, and so the Fortescue runs north, and then Doglegs to the west, and the marsh is blocked at Godiedra Hills here, forming the area. So yeah, a huge amount of water, which attracts a huge amount of water birds. There's counts of up to 500,000 when the marsh is that full. Also an important place for, or habitat for current species that are threatened, but also a refuge place for, when that other land dries up, this water will persist for most of the year through the very dry time, so it's a really important place. So we find a lot of animals coming in, but also a lot of pests with them as well, invasive species. Roy Hill Station's around here. So we're looking at Roy Hill, Hillside, Mulga Downs, Marillana, Ethel Creek. Just another map. I just wanted to show these blue points represent important native species. So there's quite a few, but it doesn't represent the whole picture, of course, because these are picked up during planning for mining, fauna studies, for putting in a road, for example. So you can see they follow the train line here and the roads. The marsh really hasn't been surveyed much, which is represented by that area, but there's still obviously a lot of species in that area. Michelle's touched on some of these, but these are just some of the species of national importance that use the marsh. Got Mulgara, the night parrot, which you've probably heard of in the news a lot recently, was thought to be extinct for some time. In 2005 and 6, it was located in Minga Well, which is on Mulga Downs. Olive python, bilbies, and leaf-nosed bats, Pilbara leaf-nosed bats. They come down to forage in the area, so very important place. And these green dots just represent important plant species, so another layer. And these Tectocornea species and Eremophilas only found here in the marsh, nowhere else in the world. So there's some unique species. So our job is to try to protect those. And we do that through a range of different programs out at the marsh. once again, all funded through FMG at the moment, but hopefully more money will come in. So the first image is of feral herbivore control. We've got a large feral herbivore control program, so looking at donkeys and camels mostly at this stage. So we've reduced impact on key areas within the marsh. As Michelle mentioned, a feral cat program. So trialling a new bait, which is a 1080 bait. No, I'll just cover that one as well. Weeds, there's a major Parkinsonia infestation east of the marsh, and it had a spread of 1 kilometre per year towards the marsh, downstream spread. So with DAFWA, the Pilbara Mesquite Management Committee, Yarrie Station, Roy Hill Iron Ore and FMG, we got together and formed a group, got some money from the mining companies through an offset, and yeah, we've put a halt to it almost, but it's probably going to take about 5 years. So I think it's a good example of working together on stations, mining companies, government even. And fire. Fire is our priority at the moment because we've only done some fire history mapping, so getting to understand fire behaviour in this unusual environment, being a marsh. We've got a lot to learn, but based on the model with Parkinsonia, we're hoping to work with industry who surround the marsh and the pastoralists as well, who surround the marsh and are our neighbours, to come up with a sort of a collaborative plan for fire management. It's a tricky one though. The CIRO released this report last year. Obviously most of you guys have read it. It highlights that out of the 53 conservation significant species in the Pilbara, about a quarter will be lost over the next 20 years if we don't prioritise the management that we do, our strategies. So we're taking this on board. And for the Pilbara, the top three were, in terms of land management, conservation land management that is, feral herbivore management, creating predator-proof sanctuaries and managing feral cats. So I've decided to give 2 case studies, one on feral herbivore control, just quickly, and feral cats to show what we're doing out on the marsh. So in October last year, the marsh was dry by that point. Each year there's inundation, and if the cyclone comes far enough inland, it pretty much fills the marsh. But normally there's still quite a bit of water, but by this point there was no water on the marsh. But there were some permanent springs, mostly on Roy Hill, and as you can see, there's animal tracking right across the marsh, probably to graze, but also to come back to the water. Yeah, quite deep gully erosion, and there's wallowing marks here along the riparian area, and there's some horses running through cakebok bush, which is a weed, spreading it. So trying to find out as much as we can about horses, they're quite difficult. So with the Pilbara Regional Biosecurity Group and DAFWA, 2 years ago we commenced a Judas donkey program, which is an extension of their current program across the Pilbara, and it's a fantastic program. I realise that most of you people are aware of this program. I just wanted to show the basic concept of it. So first step is to locate donkeys or donkey mob or group by helicopter. That's the hard bit because they hide in creek lines and in mulga. They're chemically immobilised using a vet or a trained biosecurity officer.
I thought you were going to say that's a Kiwi just ready to jump out.
Which one? So tranquilised, fitted with a VHF collar so we can locate it again. It takes about, I don't know, 15 minutes. That's the animal being released by Mick. Most of you guys probably know. It goes off to find its mob again or attract a new mob. So that's the collared animal there. It's found its mob. We go back out again and track that collar via VHF signal and remove its friends. And she'll find some new friends. So she's okay. We found it very difficult to monitor the progress through aerial surveys because once again, these donkeys seem to be very elusive. They hide in creek lines and in thick mulga groves. So we use cameras for the first time, which are remote sensor cameras. I've got one here, a bit of a show and tell. So just pass this around. So basically we set this up in the ground, and I think there's probably some practical uses on stations as well for feral animals and maybe feral people. You stick them in the ground, and if an animal walks past day or night, it will take a picture. So pass around, have a look. So this is an example. We set up monitoring stations around bores, and this is Minga Well. Represents a camera here and here. So we knew donkeys needed to drink. It's pretty obvious. And we knew they travelled down creek lines, so we stuck these cameras in creek lines leading to water basically, and we recorded the traffic, so number of donkeys coming through the creek line per hour. And then we compared it numbers before to numbers after we did a shoot to see if there's any sort of difference. And here's some, just quickly on these rough stats that we do. We had 3 treatments on the top, so 3 wells where control work was done close by, and 2 controls where no control work or no shooting took place. So basically, these are the impacts, shoots, March, May and July. The Y is average daily donkey densities or traffic coming through. And red is before the shoot, blue is after. So you can see there's a drop mostly. So in this well, over the year, there's a 37% drop in donkey traffic. So the program's working. And the controls actually increased in number. Now Minga Well was interesting because the bore pump stopped working over this period. So there was almost no donkey activity or cattle activity, which is kind of logical. But it makes us think about having a combined program, not just shooting, but combining it with maybe progressively decommissioning bores strategically with the pastoralists, because there's still some operational bores in the marsh already. We also fitted satellite collars to horses, trying to learn more about their home range to install a buffer distance around the marsh. So the idea is you remove or muster out or somehow take away the resident population in or close to the marsh, and if you have a home range distance out, it's difficult for the animals to migrate back in. But I just wanted to show, these are all horses, 11 collars, which is basically the tip of the iceberg, and it's pretty much the same size as the marsh in terms of area. So that's probably about 1% of the population. So big impacts. So another program is the feral cat baiting that Michelle touched on. It's a 5-year program sponsored by the Christmas Creek Water Expansion Project. And we use Eradicat bait, which is like a chipolata sausage size, made up of kangaroo meat and chicken fat and some secret herbs and spices. And also 1080, which is a poison. You probably all know about 1080, but it's a poison that is found naturally in the environment in many plant species. So there's a high tolerance from our native species to 1080 in Western Australia. So we use it as a tool to manage cats being introduced. Just quickly, that's our baiting cell, 100,000 hectares. That's FMG's mine up the top there, north of the marsh. So we drop 50,000 baits, which is a lot, 50 per square kilometre, across the marsh. We avoid the water because it spoils the bait. And talking to Marillana, Mulga Downs and all the neighbouring pastoralists, they didn't really want us to get too close to the bores because it's going to potentially scatter cattle and frighten them and may not come back to even drink for a while. So we put 2 kilometre buffers around them just to ensure that we didn't do that. These are just snapshots of the baiting day, doing a briefing. Unfortunately, with timing, that we do this when there's normally a muster on, so logistically it's quite difficult, but we work together to make it happen. There's some of the baits where the unfortunate bombardier has to sit in there with stinking baits and basically drop them down a chute, which goes into a carousel and drops the baits based on a GPS location. So it's fairly precise. These are the baits again. There's a biomarker within the bait called rotamine. So if a cat ingests the bait, we can pick up the trace within its whiskers out in the field to prove that it's eaten the bait. And that's just sweating the baits out on the racks before they go up to make the lipids come through and the fats and oils to make them nice and juicy for the cats. We've got a monitoring program. So there's this thing here is the lure. That's the lure, and there's one of the cameras. So the idea is to get the cat to come in and its photos taken, and then we use that as an indicator of how many cats are occupying the area. That's how we find out if the program's working. So number one is the initial lure, which is Christmas tinsel. You can see the habitat's quite low, shrubby. So an animal can see that from a long way away, get it a little bit closer. And then there's a secondary lure, which is a turkey feather, no expense spared, just tied to a bamboo stick. It flaps around in the wind, it creates a bit more interest. You all know what cats are like, it gets a bit closer. And then finally, in this jar, there's a pheromone, and a cat will come and have a sniff at that, and a photo is taken. So that's that's results from last year. It's just showing that in the area that we baited, there was a decrease in the indice of how many cats occupied the area before baiting to after baiting. Yeah. These are just images captured using that system. It works quite well. So it's a cat with a bird, not a night parrot, but some sort of bird. And this cat's got a collar on it. Good spotting. Yeah, it's one of our pets. We collared it. We trap them and collar them to learn more about their behaviour and movement, and once again to see if they go into the bait cell, eat a bait, we can trace it to show that this bait's working. Because for a while it was under a trial. I don't know if this is going to work, but I was just going to bore you with an interesting movement. If I can, is there a mouse? Have you got a mouse or something? Well, maybe this won't work. No, forget it. What it was going to show was we put a collar on a cat, trapped it here, and it stayed around its home range for a while, and then suddenly it went down one of these tracks into Cloudbreak Mine, straight to the village, got its crib, so a full belly, and came back out again. So, but that was useful information. We use that to engage with FMG more to say, look, we're getting rid of these cats in the marsh, but they're going to keep coming in unless you either join our program or start some sort of proper program on the mine site, which I've done and done very well. And this is just another way to look at the results, which I kind of like. It's the modelling part of it. So the stars represent where cats were captured on camera before the baiting, and the yellow is after the baiting. So this is the bait cell where the baits were dropped, and these are our controls where no baits were dropped, just to make sure that we could get a result that's due to an environmental factor, like the well drying up before with the donkeys. Nothing to do with baiting. So using this information, we worked out the occupancy rates of the area. And this is before baiting and after baiting. Basically, where there's a darker shade shows where there's a higher probability of a cat occurring. So you can see a clear difference. In fact, the controls went up a little bit, but basically where we baited, the area being occupied really dropped. So it's working beautifully. But what we need to learn, we're looking at, with donkeys and most of our projects, we're looking at treatment. So we're looking at results comparing before and after we bait or before and after we shoot. But we need to look at over a longer time period between years, because I'm pretty sure with the cat baiting and also the donkey program, they're just coming back in. So it's where these buffers become important too. So that's pretty much it. Thanks very much.